Hello dear all, I am Yash Kumar. Welcome you all in my lecture of 3-dimension geometry. In this lecture, we are going to discuss about the planes, how it works in our daily life and what the planes have, the equations and its geometrical and mathematical interpretations. To understand this concept of planes, we have to understand the basic concepts of two-dimensional spaces and its equations, equations of the straight line in 2 dimensions, and 3-dimension shapes. In this lecture, what the objectives we are going to discuss about the visualization of planes and its equations. That means how you can visualize plane in our daily life and how it works. Whether you are standing on a plane or not, whether you are moving in a plane or not, what the equation of plane is, what is the general equation, what is the vector form of, what is the intercept form, and all these things we are going to discuss about. Detailed analysis of planes, of course, equations of the planes and its daily use in your daily life. Let us see how the introduction to the 3-dimension coordinate can be understood. So we have understand till now in our previous classes about the functions, which is a machinery that is given by y is equal to fx. Like what we give to a function f, that is your independent part, and what we obtain from this function y is your dependent part. That means with one independent and one dependent variables. So in such case, we were working in two-dimensional spaces. Using two-dimensional spaces, we have two numeral axes that allow us to identify every point in the plane in two-dimension figures with two numbers only. Now, we want to talk about three-dimensional spaces. To identify every point in the dimension, we require three numeral values, that is three numerical values, that is the x-axis values, the y-axis values, and another axis that is called z-axis values. So actually what it is, if I think about, so initially we were studying about this only, that is called x-axis and y-axis. They are both are perpendicular to each other. Make sure this thing, they are perpendicular to each other. Suppose if I take a plane that is perpendicular to this our paper, so this is your x-axis, so this is your x-axis, this is your y-axis, so this will be your what, this will be your z-axis. That means an extra plane or an extra axis that coming outward from the paper. So in that case we could, for example, add the third axis, z-axis, with the positive axis coming straight out the page, that I told you practically by my hand, and the negative axes are behind your positive x-axis. Similarly, I can talk about here. See, so this is your x-axis, this is your y-axis, and this is your z-axis here. So the behind all the parts are negative axes. Okay. So in this way you can search out x and z comprises xz plane, z and y comprises yz plane, and x and y comprise your xy plane. So the things are going with x, then y, and then z, that is in anti-clockwise direction. So this is very important to understand the coordinate systems, like x comma y should be there, not y comma z. Okay, so hope you understand this thing. So if I introduce this part, the three-dimensional Cartesian system is formed by a point called the origin and the basis, consisting of three mutually perpendicular vectors that I told you by my right hand rule here. So this was the thing that I am going to talk about here in the figure, that is all the planes are actually perpendicular to each other. So make sure this thing, they all are perpendicular to each other. Okay, so hope you understand this result here. These vectors define the three coordinate axes, x-axis, y-axis and z-axis. They are also known as abscissa, ordinates and applicable axis respectively. So here this is the origin where you have all the joints of x-axis, y-axis and z-axis, and that formally denoted by letter O. Okay, capital letter O. Let us see how the equation of plane works in three-dimensional geometry. What is a plane? Where we are standing, is it a plane? Yes, of course, it is a plane. That where we are standing, that it is flat. It may be inclined by some angle with the horizon, that is a different thing. So, what is a plane? Plane is a flat space, two-dimensional surface that extends infinitely far. A plane is two-dimensional analog of a point, 0 dimension, a line, 1 dimension and 3-dimensional space. So a plane in a 3-dimensional space has some equation that contains three variables. Actually, plane contains three variables: x, y and then z, and some constant value, of course, that gives you some inclination of your plane with respect to your horizon. So if I have some general equation of plane, so it can be given by ax plus by plus cz plus d is equals to 0, where a, b and c and d are some constant terms, and where a or they all are actually what, a, b, c and d, they are actually at least one constant term should be non-zero. Make sure this thing. Okay, so in this way I can understand, or you can understand, the plane in three dimension figure. You can easily plot the hyperspaces, you can easily plot in your spaces, you can easily understand the plane, you can easily understand the slope, you can easily understand the angles. Actually all are the same things, you can run over. So all are actually the same things. A three-dimension coordinate space is determined by a point and a vector that is perpendicular to the plane. Suppose you have been given some 3 points in a space and you have to find the equation of plane from the given 3 points in the space. Let us see an example to understand this concept. Suppose P is a point, Q is another point and R is another point with some coordinates 1, 1, 1 and 1, 2, 0 as a point Q and -1, 2 and 1 as point R. We seek the coefficient of the equation. This equation is called the general equation of a plane. So in such case, ax plus by plus cz is equals to d is an equation of plane where p, q and r must satisfy this general equation of plane. So for point P, if I am writing here, putting the value of x, putting the value of y and z here in this equation, so we are getting an equation of a plus b plus c equals to d as a point P, x equals to 1, y is equals to 1 and z is equals to also 1. Now in the same way, for point Q also, I can put all the values of x, y and z respectively. So what the results are getting here? A plus 2b plus 0 times of c, because z is 0, so 0 times of c is equals to d, and similarly in the other case minus a plus 2d plus c is equals to d is here. Subtracting the first equation from the second equation and then adding the first equation to third to eliminate a to get some equations. So actually the thing is, you have to solve all the three equations simultaneously in such a way that your values of a, b, c and d you can obtain. So by solving these all the results, you can get some result here. Okay, so I can get the values of a, b, c and d. On solving these all the equations, what is going to happen? So the equation with a non-zero constant left to choose is d times of 1 by x plus d times of 2 by 5 into y plus d times of 2 by 5 into z is equals to d. So d is something like common, so I can take something like common. So we are getting here a result that is given by x plus 2y plus 2z equals to 5. So in another way, I can have some intercept form. So I can give this as dividing the whole equation by 5, as I am putting my constant part as 1, so I can divide this complete equation by 5. So what is happening? So another choice we would like to write here, 1 by 5 into x plus 2 by 5 into y plus 2 by 5 into z equals to 1. So you will see this is another form of equation of plane. So we will see in the next slide. So what the thing is going to happen with the next type of form of equation of plane. Suppose I am looking for a vector equations of a plane. So that means how I can represent this in a vector form. So you have studied a vector coordinate system also, vectors also, what the vector meaning, what the scalar meaning. So I am giving this concept here. So a plane in a space is defined by 3 points. You know about this thing. So 3 point is very important, or by a point or a normal vector to the plane. Then the scalar product of vector p1p is equals to r minus r1. That means it is actually a position vector. So what is happening here? Suppose p1, you can see in the picture here, p1 is a vector here in the space, p is another vector here in the space. So if I want to get the position vector of p1p, so what is happening? P1, that means I should get the value, get the coordinates of p1 in term of ijk and the value of p also, that is okay. So I can get here as r minus r1, where I am going to talk about here to draw what is p1. P1 has a coordinate system like x1, y1, z1, and of the plane to any point P, P is given by some point, that is x, y, z of the plane. And the normal vector, n is what? N is your normal vector. Normal vector, I am giving a general thing here, that is ai cap plus bj cap plus ck cap, which is 0. So that means the scalar product, that means called, I can say the dot product of these two vectors must be equal to 0 because it is perpendicular to your result. Okay, that means normal means what? Normal means what? Angle between the two numbers, angle between the two vectors is going to be 90 degree. So in that case, I can say that 90 degree, that means what? Product of two vectors, two perpendicular vectors. I would say like perpendicular vector is very important. Okay, so cos of 90 degree is going to be 0. In your last slides of vector analysis or vector algebra, you have well known what is the dot product of two vector quantities. When the angle between the two vector quantities is 90 degree, then what should happen? So it must be equal to 0. So by the same concept, I am revolving here. So r minus r1 dot product with n cap, that is normal product, okay, normal vector, is going to be 0 here, which is called the vector equation of the plane. So let us do some more things here. Let us understand more precisely here. So what the equation r minus r1 comprise? So I can have the dot product of these vectors, that is your r minus r1, and with your n cap, that is n vector, that means your normal vector. So what is r minus r1? It is simply x minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap is a dot product with a normal vector that is given by ai cap plus bj cap plus ck cap that is given here, and its product is 0. So you know the dot product of two vector quantities is going to be I with I and j with j and k with k, because I dot j is going to be 0, j dot k is also 0 and k dot I is also 0. So I can have the scalar numbers here. So in such case I am getting some result here, that is x minus x1 into a plus y minus y1 into b plus z minus z1 into c. That means your I cap, the number with I cap is going to multiply with I cap, j cap is going to multiply with j cap, and k cap is going to multiply with k cap, okay, respectively. So the general equation of the vector is of the plane in three-dimensional space is given by ax plus by plus cz plus d is equals to 0. What does the d means? D means it is given by, like, this is x1 into a, y1 into b and z1 into c. Taking the other side, these are the points at x1 comma y1 comma z1. Okay, so in this way you can have another equation that is called vector equation of plane in three-dimensional spaces. So hope you have understand this vector equation of planes, how it works and how it is can be easily understandable by using some vector quantities and its dot product. Let us talk about some intercept form of equations of the plane. So in the previous problem that we had discussed in the previous slides, what was the intercept form? Intercept form means what? As the like your intercept means, that means it must intersect with some axes. So in the same manner, here you have a plane, and it has some intercept on its axes. You can have here on its axes. Suppose here x-axis, y-axis and then z-axis. A is your x-axis, B is your y-axis and C is your z-axis. So the intercept on A is going to be at point A. So the coordinate will going to be A comma 0 comma 0, and the intercept at point B is going to be on y-axis. So the coordinate is going to be 0 comma small b comma 0, and in the same way the intercept at point C is going to be 0 comma 0 comma C, that is z-axis. So here if I want to get the result, so what is happening? Since A lies, what is A? A lies on the x plane, so I can have, and rest other part are 0. So I can write my A comma 0 as AI cap plus 0 j cap plus 0 k cap. So 0 j cap and 0 k cap can be vanished here, can be cancelled. So the only thing is going to happen here is ai cap dot product with your n cap. What is your n cap? If I think about n cap, n is your perpendicular vector or some normal vector. Okay, so in such case, which is going to be q because it is a plane. Okay, so I can have, which gives something like I dot n vector is equal to q by a. Similarly, for y-axis and for z-axis also, I can get the result as j dot n cap is equal to is equals to q by b, and similarly k cap dot n vector is equal to q by c. So I can have put the value of r vector. What is r vector? R is your xi cap plus yj cap plus zk cap. So I can put the value of x, I can put the value of I cap, I can put the value of j cap, and I can put the value of k cap also. So what I can do here, I can going to put all the values here inside this part. So what is happening? So actually what r dot n means, r dot n is going to be q as by the definition of equation of plane in the vector form. So I can have x times of q by a plus y times of q by b plus z times of q by c is equals to 0. So since you are able to see that q is common in your whole equation, so I can have something like, take common q, so you are getting equation that is given by the intercept form of equation of the plane. So dividing by q, we get x by a plus y by b plus z by c equals to 1. This is called the intercept form of equation of the plane. Having the intercept a, b, c on x, y and z axes respectively. So it has some intercept. That means your plane intersecting x-axis at point A, your plane intersecting y-axis at point plus B, and your plane intersecting your z-axis at point C. So what will be the coordinate at point A? Will be a, 0, 0. What will be the coordinates at y-axis? Is going to be 0, b, 0. And similarly, what is the coordinate of your z-axis? That means intercept of your z-axis is going to be 0, 0, c. So hope you have understand this intercept form of equation of plane. Let us discuss some problems on the equation of plane. So my problem is, find the direction cosine of normal to the plane and the length perpendicular from the origin to the plane. So in such case, plane is given to you. What is the plane here? R dot some vector is given to you, okay, which is 3i cap minus 4j cap plus 13k cap, which is equals to 5. So in such case, what your d vector means? D vector is going to be 3i cap minus 4j cap plus 12k cap, and what is your q here? So q is equal to your 5. So you know that you need to find the unit vector. What the unit vector means? The unit vector means you have to find something like d vector. Unit vector of d vector is going to be something like d vector divided by modulus of your d vector, and which is given by your vector, that is 3i cap minus 4j cap plus 12k cap divided by modulus of this part is going to be 30. So I can have here something like what, r dot your d vector is equals to your, I can say this part as your q by modulus of your d vector. Okay, so I can get here 5 by 13. So in such case, which is the equation of plane normal to the form in the normal form? So I can have r dot d is equals to p. So in such case, from this equation we can infer that d cap is equals to this one that I told you as a d vector here, okay, is a unit vector normal to the origin. Okay, so I hope so this is very clear to you all. So direction cosines to the normal to the plane are given by your 3 by 13 comma minus 4 by 13 comma 12 by 13, and the length of the perpendicular from the origin to the plane is 5 by 13. To understand our today's concept, you have to work and work hard on the problems that I am suggesting here. Like, I am giving you some question for your practice to understand this lecture very clearly and in a very proper way, with proper and efficient way. That is the equation. Find the equation of the plane in 3 points passing through the plane. That is, the plane is given passing through the points, you can say here a, b and c, given by as 0, 3, 4, 1, 2, 0 and minus 1, 6, 4 respectively. Find the direction cosines of the normal to the plane and the length perpendicular from the origin to the plane, given by r dot I cap minus 4j cap plus k cap is equals to 2 here. What you should do here again, you have a d vector here, So you know that it is q here, r dot d is equals to q. So you can get here normal means what? Normal means something looking like d cap you have to find here. So d cap is going to be d vector by modulus of d vector. So I can have some result here that will modulus will going to some result that will give you some direction cosines, and in the same manner I can have the length by q by modulus of d. Find the vector in the Cartesian form of equations of the plane which is at the distance 12 unit from the origin and the perpendicular to this 6 cap plus 2 cap minus 3 cap. Similarly, you have another problem. Find the vector and the Cartesian equations of the plane passing through the point with position vector that is given by 4 cap plus 2 cap minus 3 cap and the normal vector 2 cap minus j cap plus k cap. Hope you have enjoyed today's lecture. So thanks for joining my class and hope you have to work hard and go for this.